We started discussing about the forced response of series RLC circuit and parallel RLC circuit. So we are now solving some of the problems on these things. So note down one problem on this. So this is 20 Henry. This is I, voltage V. So this is 3.5 U of T. 3.5 U of T. And its value is 0.2 farad. For T greater than or equal to 0, find I of T and V of T. For T greater than 0, find I of T and V of T. Okay.
Sir,
Yes.
in that particular question, R is not present means alpha
R is
0
not there.
means alpha 0, na?
Alpha is 0.
Okay, sir.
So what kind of circuit it is? What kind of circuit it is?
Parallel LC.
Parallel LC circuit, right? It's a parallel LC circuit. So you find out alpha value. So what is alpha?
1 by 2 RC.
1 by 2 RC, right? So its R is 0. So that means what is the value of R? What is the value of R? So in this circuit, what is the value of R?
Infinite.
0. Infinite, right? So R is infinite, right? So here we assume that we have some resistor is there, okay, and its value is equal to infinite.
Sir,
Yes.
sir, resistance will be sir 0, na sir?
1 second. Just a minute. 1 second. I got some call. Yeah. Right. Where we are? Yeah. So here alpha equal to 1 by RC. So here we assume that we have some infinite resistor here. Similarly, in case of series circuit, right? So if you have only these two are present, right? So what is the value of resistance?
0.
0, right? So here thing is that why we are not assume that this is 0 resistance, right? So if you assume that this is 0 resistance, so whatever the current that there, right? So that will pass through this path only, right? Understood?
Yes, sir.
Okay. So we assume that in parallel, we assume that we have infinite resistance in parallel and 0 resistance in series circuit. So here R equal to infinite. Similarly here R equal to 0. If you assume infinite here, infinite resistance means open circuit, right? 0 resistance means short circuit, right? If you assume 0 resistance, that means it will be short circuit here. So there is no meaning of this, right? Similarly, if you assume that this is open circuit, right? So that means this is open circuited again. So there is no current flow here. Okay. So therefore, the thing is that in case of parallel RLC circuit, if R value is not given, if resistance is not present, in that case, so R equal to infinite. In case of series circuit, if resistance is not given or if not present, okay, so in that case, R equal to 0. So what is omega naught value?
By root under LC.
1 by root under LC. What is its value? So what is its value?
1 by 2.
Half.
0.5, sir.
0.5.
How much?
0.5, sir.
0.5. So what kind of circuit it is?
Underdamped.
Underdamped, sir.
Alpha is less than omega naught, right? So this is underdamped circuit. Okay. You can also cross check this one, right? We are studied on one of the class, right? Underdamped response is having sinusoidal thing, right? Sinusoidal means sinusoidal transients. Okay. So now what is the solution for this one? So for now, what we have to calculate, omega d we need to calculate, right? What is omega d now?
0.5.
So omega d is
0.5 on
omega
this
naught
one.
square minus alpha square, right? So that is equal to omega naught, so which is equal to 0.5 radian per second. Okay, so this is radian per second. So now what is the solution for, I of t? Or what is the solution? So what kind of solution we can expect?
A1 cos omega dt plus
Like for example, if it's I of t or V of t, for example, voltage across capacitor, if you are calculating V of t, right? So A1, what is the first term? E to the power of minus
Minus
alpha
alpha
t, right?
t.
So A1 cos, what is the next thing?
Omega dt.
Omega dt plus
Plus
A2
A2 sin omega dt.
sin
Sin
omega
omega.
d. Yes,
Yes, sir. Plus V infinite.
that's all, right? There is no j or no I here, right? In one of the class we discussed that and we clarified that. Right. So what is this value? V of t equal to, so now it will be A1.
sorry
Yes.
infinite steady state value also there, na?
Yes.
Steady state value.
Yeah, it's steady state value. V infinite, sorry. So what is this value? So it will be A1 cos 0.5 t plus A2 cos, sorry, sin 0.5 t. And what is its infinite value? What is its steady state value? What is its steady state value?
0.
Under steady state, this circuit will be something like this, right? So you have a capacitor here
0, sir.
and inductor here.
So 3.5 only, sir.
0.
Okay.
3.5, sir.
Why 3.5?
0, sir.
This is
0,
3.5
sir.
amperes, right? So this
It is
voltage, this is open circuited and this is inductor. This is short circuited.
Yes, sir.
So what will happen? Whatever the current that flows through here, and there is a short circuit across the capacitor. What is that meaning? So its voltage is 0 simply. Okay. Understood?
Sir, voltage across capacitor at infinite, sir, will be 3.5 now.
Why
It is current.
3.5? That is current source, no?
Actually, yes, sir. Okay, sir.
Okay. So what you left now? So this is 0, right? So you have some initial conditions are there, right? So what are those initial conditions? So first thing, so V of 0.
Is
So what is
0.
V of 0?
0.
What is V of 0? 0 volts,
0,
right?
sir.
0 volt.
What is I of 0?
0 ampere.
0.
Amperes, right?
Yes, sir.
Okay. So what is the another one that you require? dV of 0 by dt. Okay. So what is dV of 0 by dt? What is this initial condition?
Minus
0.
What is the formula?
minus
Oh.
R I naught plus V naught upon
Minus V naught plus R
R
R
I
I naught
naught by
RC.
RC, right? So what is this value?
Minus I naught
0,
upon
sir.
0. 0 only.
0,
0
sir,
only,
overall.
right? So it will be 0 only. Right. So now, if you substitute the first equation, so A1 cos 0.5 t plus A2 sin 0.5 t, which is equal to, this is the one, right? So V of t. So we know that V of 0 equal to 0. So substitute here. So what you will get?
A1 equal to
A1
0.
equals to 0.
A1,
A1 equal to
A1
0.
equal to 0.
Yeah.
Or A2, what you will get?
A1 equal to 0.
A1 equal to 0, right?
Yes, sir.
So now, so dV of 0 by dt, this value is also 0. So what it implies?
A2 equal
0.5 into A1 sine, you have minus here, right? Sine 0.5 t plus 0.5 into A2, okay, cos 0.5 t. This is correct?
Yes, sir.
Yes, sir.
Substitute t equal to 0 here, minus 0.5 A1. What you will get? No,
0.
A2.
0.
This is equal to 0.
0.
A2 also 0.
Yes, sir.
It is also 0.
Sir,
Yes, sir.
sir,
Yes.
sir, in parallel connection, this formula we are not using. Na? Relation is finding from inductor and capacitor voltage.
So dV of 0 by dt. What is dV of 0 by dt?
Sir, 1 by C into I of 0, IC of 0
1 by C into
into IC of 0.
IC of 0, right? Okay. I think somehow, wait a second. So now we are considering the currents first. Okay. So what you will left with?
I infinite
A1
on.
And I infinity.
plus
I
I
in-
infinite.
plus I infinite. So A1 cos omega dt plus A2 sine omega dt, right? What is I infinite value? 3.5.
Yes, sir.
Okay. So now I think now you will get. So this is I of t, right? So what is I of 0?
0.
0.
0, right?
Zero,
So
sir.
that means from this relation, what you will get? A2,
A1 is
A1 plus 3.5 equal to 0. So A1 is 3 minus 3.5. Agree?
Yes, sir.
Yes, sir.
A1 is minus 3.5. Okay. So now what else you have?
D
by dt of I at 0.
of I 0 quantity.
I of 0 by dt.
dt.
This is equal to 0, I think.
Yes,
In
sir.
previous slide, we calculated this is 0. What it
Yes, sir.
implies?
A2 is also 0.
So from this A2 is 0. A2 is 0 from this.
Yes, sir.
So what is the answer you got?
3.5 minus 3.5 cos t by 2
3.5
minus 3.5 cos omega dt.
this is the one.
Yes, sir.
Okay. Yeah, correct one, I think. That means 3.5 minus 1 minus cos 1 minus cos 0.5 t. Okay, this is the answer for current I of t. Right. So now you find V of t. What is V of t?
1 by
dt.
c, 1 by c integral 0 to-
by C, sir.
So here, if you observe that voltage across this one we required, right?
Capacitor and both are
Okay,
same.
so
sir.
voltage across inductor and voltage across capacitor both are same, right? So therefore,
LD by dt.
which is equal to L into di of dt, right?
Yes, sir.
Okay, so which is equal to voltage across inductor. So what is the answer for this?
Seven sign.
What is the answer? I think sine term will come, no?
Sir, 3.5.
Yes. Sine? I think 3.5 sine
0.5 T.
0.5 t.
Sir,
Yes.
why can't we use integral IDT by C here?
Both are same only, no? Okay.
Uh,
So this is easiest way. Instead of calculating the integration, this is the easiest way, no? That's why you use this.
Sir, if we integrate it, won't we get something with T as well?
If you integrate,
If we integrate I, won't we get
no, how
3
to do the integration? You tell me v of t, right? So which integration?
Hmm.
What is the formula?
Integrating from 0 to T, I of dt by C.
0 to
T. 1
integration
by
of
C
1 by c integration of 0 to t I of t
uh,
dt,
dt
right?
plus V at 0.
Plus
V at 0.
v at 0, right? If you do the same, you will get the both will be same only. Will get, okay. But this
Sir,
will
it
be the
is-
easiest. Yes.
Sir, this current is through inductor na? IT. I is a function of time.
Yeah, this current is, that's why I have doubt. This
So
is not
we
valid.
can't
No, this
use this
current
na,
is
sir?
inductor current. We
Okay,
can't
sorry.
use this one. Okay.
This current
Got
will
it,
be
sir.
capacitor.
This is for inductor current.
inside.
Okay. You require only capacitor current. So the only way is this one only.
Sir,
Yes.
sir, how to, sir, means identify whether we need to apply the formula for current or voltage, sir? So just like this question.
These questions are rare only. Okay. Right. Okay. These questions are very rare. What my observation is, in case of if this is the circuit, right? I think you need to start with the current. Okay. And if it is series circuit, I think we need to start with the voltage. Why? How to decide that one means, because we have some because why the problem is erased in this previous case. So this is the one, right? So here there is the voltage across, this is 0, and its final value is also 0. If you notice that, so in the solution, so why this problem is erased, because v infinite is 0, right? So this particular value is 0. So that's why you are getting a1 0 and a2 is also 0. Okay. And if you observe that, because we have this 3.5, its a1 value is some finite value obtained. So what my observation is, if you have a parallel circuit, so it is good to start with current. It is a series circuit, it's good to start with a voltage. So this is only one case, right? So here, this is a special case. So where you have R value is infinite, or where you have R value is 0. You will not encounter much of these problems. So this is a special case actually. That's why we discussed in the class. If you observe that, so this is the current, right? So this is the voltage across capacitor. So how this voltage across capacitor is varying, if you notice that this is sinusoidal and it is varying like this. So its magnitude is 3.5, its peak value is 3.5, and it is undamped. Right.
There will be 3.5 into 20 L.
3.5
You
into
not
20.
Yeah,
Oh.
L you
That
have not
will be
multiplied.
correct,
I think
sir.
you are
That
not
will be
multi-
neutralized by 0.5, sir.
Yes.
Sir, again 0.5 into 20 will become 1 now, sir.
Okay.
It's L into di of dt, right? What is the value of L? 20, I think.
Yeah, 20.
Yes, I will.
So 20 you will get here, and from that 0.5 you will get.
0.5.
How much it is?
Yes, sir. 1.
10. I think this will be 35.
35.
1, sir. 20 into 0.5.
20
sorry.
into 0.5 is 10 now.
Correct.
20 into 0.5 is 10. 10 into 3.5 is 35. So its magnitude is 35. Okay. I will check the answer again in textbook. Let me check once again.
Excuse me, sir.
Yes.
Sir, is it like we are having current source? That is why we are using I of t initially.
Yeah,
Matlab,
that's
it could be
the
like that
reason.
also.
That is the one. Okay. So answer they have given something different. 10 into 1 minus cos 0.5 t is for voltage, and for current they have given 100 sine 0.5 t. Let me check the values. 3.5 u of t, 0.2 farad, and this is 20 Henry. If this value is correct, 1 by LC, I think this is correct. 0.5 radians per second. Okay, I think that is they're given wrong in the book, seems like. Okay, leave that. So if you notice that if I of t or V of t voltage across this, so this is undamped, right? So because there is no resistance here, so it is producing continuous oscillator circuit. So energy stored in inductor, so that is charged the capacitor, and energy stored in the capacitor charging the inductor. Right. So now we'll do one more. I hope you understand the question, right? This 4 Henry and this 40 ohm and this is 10 millifarad, and this is 9 into U of t, and this is 45 volts, and its value is 10 ohm. What is the first step? What is the first step? So if this is the voltage across V, so find out I of t for t greater than 0. So this is V and this is I. Okay. What is the first step? So we need to find the initial conditions, right? So what is I of 0?
Less than 0.
What is I of 0?
4.5 amps.
What is I of 0?
4.5 amps.
So it will be something like this, right? So this is, and this source, 9 ohm source. So this will be, there is no source, right? Why no source? So it is 9 into E of t. So that value is 0. It will be something like this, right? And this is the current we are calculating. And this is open circuited. And this is 10 ohm here. And this is 40 ohm. And this is 45 volts. So what is I of 0?
4.5 amps.
4.5
5
amps.
amps.
So this is voltage across. No. What is how much current that flow here? So this is 45 divided by 10 ohm. So that is the current. So that is flowing through the resistor, right? Is this correct?
Sir, current source is giving
Sir,
zero
current
value.
source will act like a wire, na sir?
Yes,
You
it will
said
short circuit
voltage.
rest of the place.
Yeah, sir. Voltage source will act like a switch and current source will act like a wire.
No, this is 9 into U of 0, right? So that means this value is 0 amperes.
Yes, sir, but the wire
But
will
0
still be
ampere will be a
connected.
wire, na?
Why 0 amperes is a wire? 0 amperes is open circuit, right?
Yeah, sir.
So if it is short current source, so it is open circuited. If it is a voltage source, it is short circuited. What is the current that's flowing here?
Sir,
Yes.
sir, sir, in switching function, sir, you said that irrespective of current or sir voltage source, sir, whenever there is any unit step function, sir, we'll assume, sir, open circuit only, sir.
No. See here, E of t, right? E of t equal to 0 for t less than 0. Okay. So for t greater than 0, E of t equal to 1, right?
Yes, sir.
So that
Yes,
will
sir.
change with the problem to problem, right? For example, if this is the 1, right? Okay, some it is open circuited. In that case, that will be changed. We already, I think we one class we clarified this. If this is the function, right? So this is U of t, and its value is 1. So for example, you have source is there, and it is value is 30 into E of t. So what is its meaning? So this minus infinite, 0, and this plus infinite, right? So E of t equal to 0. So what is 0 voltage means?
So open circuit, sir.
Short circuit.
Short circuit, right? So it will be short circuit. Right. So what is E of t? What is E of t equal to 1?
30 volt source.
So that will be voltage source is 30 volts. The particular source is 30 volts. Similarly, for current source, it is open circuited for 0, and it will be voltage is current is present for t greater than 0. If it is a current source, some 20 U of t, right? It is open circuit here, right? For t greater than 0, for t less than 0, its value is 20 amperes. Understood? Thing is that actual in actual general sense, right? So there is actual the thing is that why we are confusing all these things. There is nothing like this U of t representation. Okay. So that is the shortcut most of them used in their textbooks. Okay, that's they usually say that the unit step response or unit step response, something like that. Unit step response or step response of a circuit. That's word. So this problem, right? What is its value? So this current is 4.5 amperes, right?
Yes, sir.
Okay. So what is V of 0?
45 volts.
45, sir. Yeah.
Why 45?
V of 0 is 0.
0 volt, na?
V of 0 is 0. Sir.
0?
Sir, 45 only.
So
What is the
45,
current
sir.
that
V of
flows
0
through this
equals
10 ohm
L into
resistor?
D of
What
0
is the
by T.
current? What is the current that flows
4.5
through?
amps.
So this is short circuit, right?
1.5.
No, this is short circuit, right? So that means this
Yes, sir.
capacitor voltage is 0. So this is 0 volts. Okay. Understood. So I of 0 is 4.5 amperes and V of 0 is 0 volts. So what is the next step? So this is the circuit. We need to formulate this into a, if you observe that, we can bring this circuit into parallel RLC circuit, right? So how to bring this in a parallel RLC circuit? how to bring this down into a parallel RLC circuit.
We find the I of t.
If you observe that, right?
Got
So
it,
this
sir.
is now the circuit will be something like this, right? This is 45 volts and this is 10 ohm. And what is the value here? 9 into E of t, and here 10 millifarad, and this value is 40 ohm, and this is inductor. What is this value? 4 Henry. So how to bring this into a parallel RLC circuit?
We have to convert that 45 volt and 10 ohms into current source
Current
and
source.
parallel resistance.
Right. So if it is 45 into 10 ohm, if you convert into current source, what is the current source value? What is the current source value?
4.5, sir.
4.5, right?
4.5 ampere.
In addition to that,
Plus-
we have 9 ampere current source is there, right?
Yes, sir.
So what is the overall current? What is the overall current?
13.5.
It is 4.5 plus 9. Okay. So this is the circuit. Again, in this circuit, if these two are, what is the value of this resistor? So this is 10 ohm, right? So this is 40 ohm. This 10 ohm and 40 ohm, so both are in parallel, right? So what is its equivalent resistance?
8 ohm.
10 for 8 ohm, right? So now this entire
Yes,
thing
sir.
will be there, removed. So it is having only 8 ohm. Okay, so this is 10 millifarad and this is 4 Henry. Understood? So this is how we deduce the circuit into a parallel RLC circuit with 13.5 ampere source. So what is the next step? You need to find the alpha value, omega naught value, right? So based on that overdamped or underdamped thing, so you need to obtain the overall solution. So what is alpha here?
6.25.
Alpha is 6.25. Omega naught?
5.
Hmm? What is omega naught? 5. You're saying 5?
Yes, sir, 5.
Okay. So what kind of it is? Alpha is greater than omega naught, right? So find
Yes,
out the
sir.
response and compute the remaining things. So next, another problem. An automobile igniter, an automobile igniter is modeled by the circuit. So an automobile airbag actually. An automobile airbag igniter is modeled by the circuit The circuit is like this. We have a 12 volts battery from the car. So this is A here and B here. So this is airbag, igniter. So initially this is a position, right? And it is moved to this position at some t equal to 0 instant. So determine the time it takes, right? Time it takes the voltage across the igniter, to reach its first peak after switching from A to B. So values are given here. So this is 3 ohm. So this is 1 by 30 farad, and this is 60 millihenry. All right. So we already discussed one of the application of this second order system is airbag igniters, right? Okay. The thing is that, so usually this is airbag igniter. So whenever it sees a high voltage across, so that igniter, right? So that will start the mechanism to open that airbag, right? So here, so initially this is the capacitor. So this capacitor is at position A. So whenever some collision is detected, so what will happen is that the position of the switch is moved to position B, so that the circuit is closed, right? And it is producing a underdamped response. Something like this, right? So this is the first peak. So this will be the first peak, right? So for example, it is having some response, right? So this is the first peak. So now what we have to calculate is, so how much time it takes to reach that first peak. In other words, how much time it required to ignite the airbag. In other words, how much time it ignite the airbag. So once it detects the collision. So that we are going to find out in this. Okay. So this is the circuit. So first thing is, what is the voltage across capacitor? What is V of 0 and what is I of 0? So what are the initial conditions?
V of 0 is 12 volt.
V of 0 is how much?
12
Voltage
volts.
across capacitor is 12 volts, right? So what is the current through inductor? So that is 0 amperes.
0,
So
sir.
keep that aside. Right. So now once the switch is closed, so it will be something like this, right? The circuit will be modified something like this. So this is 3 ohm. This is 60 millihenry. What is this capacitor value? 1 by 30 farad. Okay. So this is a source free response of RLC circuit, parallel RLC circuit. So what is value of alpha and what is the value of omega naught?
by 2 RC.
What is alpha? 1 by 2 RC, right?
Yes, sir.
What is 1 by 2 RC? I think
5, sir.
Yes, sir.
what is omega naught?
Root LC.
So that is 22.36. Okay, 1 by root LC is 22.36. Is this correct?
Yes, sir.
Okay. So what kind of case it is? What kind of case it is?
Underdamped.
The dam.
Alpha less than omega naught, right? Underdamped. If it is underdamped, immediately you need to find omega D value. What is omega D?
Under root omega square minus alpha square.
What is its value?
$21.794.
21.79.
4.
Okay, 794. So now what kind of response it is under damped? So that means if we assume voltage of T, V of T, that is the one we required, right? So e to the power of minus 5t, okay, so A1 cos 21.794t plus A2 sin 21.794t. Agree? This is the one, right? So what is V of 0 and what is dV
Sir,
of
plus
0
V
by dt?
infinite.
V infinite, sir.
Why V infinite? This source free response, no? There is no source here. See here, this is no source here. So initially you have 12 volt source. The 12 volt source is just charge the capacitor and it's moving to the other side. Understood? Okay. So there is no source here, right? So what is V of 0? So this 12 volts. What is dV of 0 by dt? What is dV of 0 by dt? Minus of, I think V naught
V
plus
naught
I
plus
naught into R by RC.
RC.
So what is this value? I naught is 0, right? So minus V naught minus 12 by RC. Minus 12 by RC. What is its value? I think
Minus
minus
120.
1 by 1 RC is, I think RC is 1 by 10. How much it is? Minus 120. Is this correct? Check it out.
Yes, sir.
Okay. So with these two initial conditions, so find out this. So first one, what is the first? If you assume that V of 0 equal to 12 volts. So what kind of thing you will get?
A1 equal to 12.
A1 equal to 12 volts,
12.
right? Not 12 volts. A1 equal to 12. So what is dV of 0 by dt? What is dV of 0 by dt? So for these kind of things, so doing these things, it is somewhat trickier, right? So there is a small trick. Just remember that. So we have two constants, right? A1, A2. Okay. So we have two constants, A1, A2. So we have one initial conditions. If you assume that whatever this A1 value, so this is always, if it is voltage across this one, right, this is always equal to V of 0 only. Okay. So that is the first one. And second equation, right? Second equation. So how it will be means minus of alpha into A1 plus omega D into A2. So which is equal to dv of 0 by dt. Just check it out whether it's correct or wrong.
Sir, correct, sir.
Right?
Correct, sir.
So that is the, just simplify this one. If even though if you're doing that, so you will get the same thing only. So a1 is always equal to v of 0, and so this is minus alpha into a1 plus omega t into a2. This is not only v of 0, this is also equal to I of 0. Okay, so this is only valid for source free response. Whenever some source is present, the things will change, right? So this is for source free only, source free. So what is this value here? Minus 5 into a1 plus 21.79 a2, which is equal to minus 120. So find out a1, a2. So a1 is already 12, right? What is a2?
Sir, minus 2.75.
a2 is minus 2.75. So what is the overall solution? E to the power of minus 5t. a1 is 12, right? Cos omega, what is this value? 21.794. What is the value of this a2? Minus
2.75.
2.75, sir.
75 sine 21.794 t. So this is the voltage across capacitor, right? So this is the voltage across capacitor. So this is also equal to voltage across resistor, right? So this is also equal to voltage across resistor. So how to get the peak value of this thing? How to get the peak value?
Differentiation 0.
Differentiate
Sir.
this one into 0, right? So this
Yeah.
is the, if you observe that one, so this response will be something like this, right? Okay. So we need to find this peak value. So how to get the peak value? Right. Differentiate this one, so with respect to 0, and substitute that time period t, right? So that means at t equal to some, for example, at t equal to some x, you'll get the peak value. So how to do that? So differentiate this one, d v so from this you can calculate the value of x. So you can calculate the value of x. So this is the x seconds. So find out that x. So differentiate that one and equate to 0. So how much you got? Negative. You can make it positive, no? Because it's time.
Sir, which is minus 0.484.
Minus 484.
0.484.
No.
Yes, sir. And sir, time we are, sir, time accordingly, sir, we are getting, sir, 0.02 second.
0.02 is correct. How much you got? X, how much time you got?
So 0.02.
0.02. Anything else? 0.2 seconds. Yeah, I think it's correct only. So roughly you will get 20 milliseconds. The exact answer, just a minute, I will provide the exact answer. It's 20.68 milliseconds. Okay, it's 20.68 milliseconds. So meaning is, right, so when a crash is detected, right, the switch position is changing from A to B, right? After that, it's 20.68 milliseconds, right? So the airbag start diffusing. The airbag start diffusing. Okay, understood? So you have any questions?
Sir,
Yes.
sir, what is the purpose of this? So means entire system, sir.
What is the purpose of this one?
Yes, sir. This airbag system, sir.
Actually, the airbag, what thing is that the airbag is there, right? So that is usually filled with most of the cases the nitrogen gas or some gas it is filled, right? So for to provide that, what we say, to provide what we have to do is we need to fastly pump the gas inside that airbag, right? That you require a high voltage you required. So that high voltage is supplied by this RLC circuit. Okay.
Yes.
Okay. So that is opening at very faster rate, right? If you observe that any crash videos or something like that, so that is opening at a very faster rate. So that means that fast circuit you require some high voltage. So but the car battery is having only 12 volts, right? So with the 12 volts, it cannot pump that gas into that airbag so fast. So that's why you require this mechanism. Right. So that is so fast that, for example, if you are not wearing a seat belt, right? So even though if the airbags are diffused, right? So you will lead to death. Okay? So that's why you need to wear a seat belt. So the thing is that there are two possibilities. If you're not wearing a seat belt, for example, right? If the airbag is open, so that will be even the worst possible thing that will happen, right? So you will be damaged with the airbag, means your face will be damaged because the airbag will open right just before your face. Okay, so that your face will be damaged or your face will be crashed, right? So that's why you always wear a seat belt. So even though that airbag is diffused, right? So it will not hit your face while it is diffusing. So once it is completely diffused, once it is completely open, so then only our face is supposed to fall on the airbag. Okay. Okay. Any questions you have? Okay, we'll stop here.